and splitting it into its component colors. Astronomers can learn a staggering amount of information about an object that may be millions of light years away.
The color in the light of a distant star is mixed into a composite image at the retina of the eye. We can spread it out into an orderly array and study it. This is spectroscopy, and without it, the universe would be incomprehensible.
Light is the natural phenomenon that stimulates the remarkable mechanism of the human eye and allows us to perceive the infinite visual variety which the world and the universe have to offer. And perhaps the most pleasurable visual experience is the eye's ability to distinguish between the various colors of the spectrum, the endless variety of colors on the Earth, and from throughout the universe. We usually think of the visible light from the sun or from an artificial light source as being white. But what we perceive as white light is actually a mixture of distinct colors. And for centuries, we've known that white light can be separated into the different hues of the color spectrum, from red to violet, by passing it through a glass prism. In a classic experiment, Isaac Newton produced a color spectrum by passing daylight through a prism, then recombined the various colors by reflecting each color onto a single point. And once again, the resulting spot of light was obviously white. This proved that the various colors were simply component parts of what we perceive as white light. Since visible light is a form of energy, it's logical to assume that the various component colors represent different levels of energy. For instance, red has the lowest energy level of all the colors in the visible spectrum. Orange has a slightly higher level of energy. Yellow is more energetic than orange. And green is more energetic than yellow. Blue is more energetic still. And violet is the most energetic form of visible light. So the various components of white light, the colors of the spectrum, are really just radiations at varying levels of energy. Also, the component colors of visible light serve as the cornerstone of spectroscopy. Spectroscopy is the technique by which astronomers can determine a remarkable amount of information about a distant star by recording and analyzing its visible light.
We use the science of spectroscopy to identify elements, both here on the Earth and out in space. And it's that identification then that tells us what objects like stars and galaxies are made of. Well, it's fortunate for us that much of the material out in space is in the form of hot, glowing gas, because it's the light from that hot, glowing gas that we analyze, and from that analysis, we determine what the gases are made of. Here on Earth, most gases are invisible, and so we can't identify them just from their appearance. This room, for example, is full of gas. It's full of nitrogen and oxygen, but we can't tell that just by looking at it. This tube is full of hydrogen, and we can't tell that just by looking at it. You have to take my word for it. But notice what happens if I pass an electric current through the hydrogen and cause it to glow. We see that the hydrogen glows with a bluish-red light. Maybe a little bit hard to see in here because of our conditions. Here's a tube of helium, which is also invisible. But again, if we pass an electric current through the helium, we see that it glows with a pale yellow light. A tube of neon gas, when we pass a current through it, glows with a rather bright orange light. And finally, a tube of sodium gas glows with a rather distinctive bright yellow light. Hydrogen glows with a bluish red light, helium a pale yellow light, neon a bright orange light, and sodium a bright yellow light. Does that mean that whenever we see a bluish red light, that we can assume that that's glowing hydrogen? Well, that's tempting, but unfortunately it's not that simple for a variety of reasons. For one thing, there's thousands of substances and there just aren't enough colors to go around. But notice what happens if we take the light from the glowing hydrogen and we pass it through a prism. Prism that separates the light, divides it into its individual colors. A wonderful thing is observed. We see a pattern, a distinctive pattern of three colors: a shade of violet, a shade of blue, and a shade of red. That's the spectrum of hydrogen, and it turns out that no other element in the universe has that same distinctive pattern. The spectrum of helium, a little bit more complicated, but it's unique to helium. The spectrum of sodium is different from hydrogen and helium, but it's unique to sodium, and we see that there are two bright yellow lines. And the neon spectrum is unique to neon. And so every element